So students, today again we will see some more problems on electric potential. So again you will be having a problem on your screen. You can pause, note down the problem and then you can solve along with me. Okay, so third problem. What it states, there are 2 point charges plus 1 and minus 4 nanocoulomb 1 meter apart in air. Find the position on the line joining 2 charges where resultant potential is 0. Where resultant potential is 0. So students, in such problem, you will be having 2 cases. One point will be in between 2 charges and second case point will come outside the 2 charges where potential is 0. And here compulsory one will be positive and another will be negative. So if I take 2 charges, he has given 2 charges. So one is 1 nanocoulomb and another one is minus 4 nanocoulomb, plus 1 nanocoulomb, minus 4 nanocoulomb. So this point I will take it as A, this point I will take it as B. They are separated by a distance of 1 meter. Distance between these 2 charges is 1 meter. Now in first case, I will take a point in between these 2 charges where potential is 0. So I will denote it as a P point where potential is 0. V is equal to 0. You are required to find the position of this point. So I will take it is at a distance x from 1 nanocoulomb. So if I take this distance as x, then this remaining distance will be 1 minus x. Correct? Because total is 1 meter. This is x. So remaining distance will be 1 minus x. So you are required to find position, that is you are required to find x. So what he says, potential at point P is equal to 0. Potential at point P is 0. So potential at point P is due to this charge which is at point A. I will take it as VAP. As it is positive, potential will be also positive. It is a scalar quantity. So VAP plus, there will be potential due to this charge also minus 4. But as this is negative, potential at this point will also be negative. So minus VBP is equal to 0. So now I will substitute the values, else I will take this to the RHS. So I can write VAP is equal to VBP is equal to VBP. Now I will substitute the formula, or I will substitute the values. So potential at point P due to A. So 9 into 10 raised to 9 into Q. Charge is 1 nanocoulomb. 1 into 10 raised to minus 9 divided by distance is x is equal to. So potential due to this B. So again formula, if I write 9 into 10 raised to 9, charge is 4 nanocoulomb, minus I have considered over here. So again you don't take minus 4. So minus I have considered over here. So it is 4 into 10 raised to minus 9 divided by distance is 1 minus x. Distance is 1 minus x. Now you simplify, you will have the answer. So 10 raised to 9 into 10 raised to 9 gets cancelled. 10 raised to minus 9 gets cancelled. So remains is 1 by x is equal to 4 by 1 minus x. 1 by x is equal to 4 by 1 minus x. Now cross multiply and simplify, you will have the answer. So if I cross multiply, I will have 1 minus x is equal to 4x. 1 minus x is equal to 4x. So therefore 1 is equal to 5x, or you can say x is equal to 1 by 5 meters. X is equal to 1 by 5 meters. Else you divide. If you divide, you will have x is equal to 0.2 meters. So x is equal to 0.2 meters. This is first case. Means point P is in between these two charges. Clear, students? You can pause, note down the steps. Then we will go for the second case. So now, in the second case, you will have point P outside the two charges. So I will take second case. So there are 2 point charges, 1 and minus 4. So plus 1 nanocoulomb, minus 4 nanocoulomb, and distance between these two is 1 meter. 1 meter. Now in second case, point P will be outside these two charges, and always remember it will be nearer to the smaller charge in magnitude. Point will be nearer to the smaller charge in magnitude. Means here you will have point P where potential is 0. So P, here V is equal to 0. This distance I will take it as x. This distance I will take it as x. So again, potential at point P is 0. So if you take these steps will be same. Potential at point P is 0. So due to this charge, that is which is at point A, VAP positive. Due to charge which is at point B, if I take VBP as it is a negative, minus. Again I will take on the RHS side. Now substitute the values. So if I write formula, 9 into 10 raised to 9 into 1 into 10 raised to minus 9 divided by distance is x is equal to. Now while writing potential due to B, distance will be 1 plus x. Distance will be 1 plus x. So you will have 9 into 10 raised to 9, 4 into 10 raised to minus 9 divided by 1 plus x. In the first case we had 1 minus x. In the second case it is 1 plus x. Again simplify. Both side 9 into 10 raised to 9 gets cancelled. 10 raised to minus 9, 10 raised to minus 9 gets cancelled. So you will have 1 by x is equal to 4 by 1 plus x. 4 by 1 plus x. Now again two steps. Cross multiply, you will have the value of x. So you will have 1 plus x is equal to 4x, or you can say 1 is equal to 3x. If I divide by 3, you will have x is equal to 1 by 3, or you can say x is equal to 0.333 meters. This is second case. X is equal to 0.333 meters. Clear, students? So again you can pause, note down the steps. Then again next problem will be displayed on the screen. You can pause, note down that problem, and we will solve next one. So, okay. Now if I take fourth problem, there is a short electric dipole of dipole moment. So he has given a dipole moment, that is P, 4 into 10 raised to minus 9 coulomb meter. Determine electric potential due to dipole at a distance r. He has given 0.3 meters. So 3 cases he has given. You are required to find potential on the axis, on the equatorial line and at an angle 60 degree. So first, if I write formula for potential, V is equal to 1 by 4 pi epsilon naught P cos theta divided by R square. P cos theta divided by R square. So first case, potential on axis or axial line, So for axis, this theta will be either 0 or 180. So cos 0 is 1, cos 180 is minus 1. So V will be equal to plus or minus 1 by 4 pi epsilon naught P by R square. Now substitute the values and simplify. So this is equal to plus or minus 9 into 10 raised to 9 into P is 4 into 10 raised to minus 9 divided by R square divided by R square. So R square will be 0.09, 0.3 square or 0.09. So if I simplify this, plus or minus 10 raised to plus 9 minus 9 gets cancelled. So 9 into 4 divided by 9 into 10 raised to minus 2. So 9 gets cancelled. So if you take to the numerator, it becomes plus 2. So if I multiply to 4, I will have 400 volt. So plus or minus 400 volt. Clear, students? Now, if I take second case on equatorial line. So on equatorial line, theta will be 90, cos 90 is 0, so potential will be 0. So as theta is equal to 90, V will be 0. Potential on equatorial line will be 0. Then third case. Third, he has given theta. You are required to find potential at an angle of 60 degree with the dipole axis. So theta is equal to 60 degree. Now take this formula, substitute the values. So V is equal to 9 into 10 raised to 9 into P 4 into 10 raised to minus 9 into cos 60 divided by R square. So R square will be 0.3 square is 0.09. Now this we had simplified over here. We have simplified. So it will be 400. Cos 60 is 1 by 2. So you will be getting answer 200. So if I simplify 9 into 4, this gets cancelled. 0.09 I will write it as 9 into 10 raised to minus 2. Cos 60 is 1 by 2. So if you simplify, 9 gets cancelled, 2 if you take to the numerator, you will have 200 volt. You will have 200 volt. Clear, students? So again you can pause and note down the solution.